How's everybody doing? Excited? Ready to learn? You so happy for this lesson on logarithms? It's been so long since you've seen a logarithm. What could possibly go wrong? Nothing, right? Okay, so to talk about logarithms, let me set up a motivation behind them. So let's see if we could find the inverse function f inverse of x if f of x equals 2 to the x power. Okay, so we said step number one when finding the inverse functions is, well, if there's an f of x in there, replace it with y. So we got y equals 2 to the x. Now as our inverse step is where we switch the x's and y's, and I got x equals 2 to the y. And now I have to solve in terms of y. But how am I going to solve in terms of y? I can't take the square root or the y-th root of both sides. That doesn't quite make sense. So this is where we need what's called a logarithm. And if we didn't have a logarithm, we'd be stuck right here. So this is the reasoning behind a logarithm. So I'm going to skip to the next slide here to formally define what is a logarithm. Okay. Here it is, and this is a kind of interesting definition. This is a definition purely in words, and this is really what a logarithm is. If x equals log base a of the number y, then y equals a to the x power. Okay, that sounds a little confusing, and don't worry, I'm here to help you work through it. So I'm going to start with a couple important facts here, that whenever we take the log of a number, that is, maybe we put it in our calculator or something like that, it's going to spit out a number. That number that we find, which in this case I'm calling x right here, that number is really an exponent. And what I mean is really an exponent is it's that exponent right there. It's this, this number a to this number should equal this number y. Okay, I know. Don't worry, we'll get there. So again, and I'm just kind of rewriting what I said there. Whenever we take the log of a number, we get an exponent, like the letter x, and that number a inside the logarithm we call the base. And just like the base of an exponential function, like 2 to the x, the base is 2. Okay, so today, the objective for today is really going to be rewriting logarithms into exponential form and or the other way around. So let's just try a few examples here. So let's see if we can do this. I'm going back to the definition in the orange box there. And that little arrow here, how it's going both ways. What that means is it doesn't matter if you start with this side or if you start with that side. It works in either direction. So we're actually starting with this side. We want to rewrite stuff this way. Hope you have this written down. So if I want to write something like 16 equals 2 to the 4th, I know that's true. So when I write my log, I could write it in either way. But so what's my base? My base is 2 here, because it's 2 to the 4th power. And what's my exponent? 4. Good. And this is going to be kind of the number that we're going to log. So this is how it's going to work. We're going to log this number, this is going to be our base, and this is going to be the exponent what everything equals. So what I'm saying here is that the log, and then the base is 2, of the number 16 equals 4. And I could rewrite this the other way, that 2 to what power equals 16? 2 to the 4th power equals 16. You're going to hear me say that a lot. 2 to what power equals 16? See if you can do this for the next problem. So we're just rewriting what we already know is true as a log. Again, ask yourself, what's the base? What number are we going to take the log of? And what's it going to equal? Well, again, it's going to equal the exponent. And so log, what's the base? Good, 3. And of what number are we taking the log of? Oh boy, you guys sound so excited. 81. And that's going to all equal -3. And it might seem a little counterintuitive that we take the log of a number and it equals a negative number, but check it, this number is actually less than 1. The only way to get a positive number or a number greater than 1 to be a number less than 1 is we got to take it to a negative power, like we already did over here. And again, if I started with this, I would read it as 3 to what power equals 1 over 81. And in this case, oh, you're right. I'm so embarrassed. Who gets a sticker? Somebody got a sticker on that. That's not correct, is it? Okay, somebody gets a sticker. Old man Bessling made a mistake, as usual. Or not as usual, it's my first time. Was my first time making a mistake. Alright, next problem is kind of crazy. Let's see if you can give this one a try. Rad 2 over 6 equals 2 to over 36 all to the 1/2 power. How would you write that as a log? Told you that one got tricky, but again, think of what your base is. This is the base of my exponential. It's going to be the base of my logarithm. And we're saying 2 to the 36th power, sorry, let me say that again. 2 over 36 to what power equals rad 2 over 6? Cool. Okay, believe it or not, this next slide is essentially the last part of the lesson. And last part of today's lesson, not all of 11.3. There's still graphing to go, but I figure we'll call it here. We'll call it this. See if you could solve this problem. Log base 4 of x equals 3. And the trick to solving these problems is to rewrite this like I'd mentioned. Again, I'm just going to go back a couple slides and look at that definition. Now we're on this side, so we want to rewrite this guy that way. So again, I want you to get used to writing these. When I look at something like this, I'm literally saying 4 to what power equals this, and clearly in this case, so we would rewrite this 4 to the 3rd power equals that number x. And what's 4 to the 3rd power? Good, 64. And that's the answer. And if you don't believe me, you can take the log base 4 of 64 and it should be 3. Okay. How about the next one? Log base 36 of the square root of 6 equals x. Can you rewrite that and try to solve it? So we're going to rewrite this 36 to what power, which in this case is x, is going to equal the square root of 6. Yikes. Well, I know that the square root, so 36 to the 1/2 would equal 6, so that means that 36 to the 1/4 power is going to be the square root of 6, because giving us 36 to the 1/2 would be 6, and then to get another square root I'd have to take that to another 1/2 power, so that would be x equals 1/4. And that, believe it or not, is the lesson. Too short? Well, let's start out just practicing being able to rewrite logarithms in both directions. Thank you for watching.